Okay, so in this section, we are going to be finding the area again. We're going to be talking about trapezoids. So just to kind of review, what we did yesterday was the area of a parallelogram. So whenever you're finding the area of a parallelogram, remember that the area for that is going to just be base times height. Okay, so the base in this picture is going to be this 20 that you see, and the height is going to be this 18. So I was trying to find the area here. I'm going to take 20 times 18. Okay, that's going to give me 360. And you're also going to have to select the label that this is. So anytime you have area, you're looking for squared of your units. So that's going to be centimeters squared. So that was what we did yesterday. Now, today we're going to do the area of a trapezoid. Okay, so formula for the area of a trapezoid. Okay, it's going to be very similar to a triangle. Base and height are going to be needed, except for you have two bases. So you're going to have base 1 plus base 2 times the height over 2. Okay, so yesterday for a triangle, it was just base times height divided by 2. The only difference for a trapezoid is that you're adding the bases and then times the height divided by 2. So your bases in a trapezoid are these sides that are running parallel to each other. So in this case, the 8 and the 12. So when I'm going to find the area here, I'm going to be adding up 8 plus 12. My height is going to be my distance between my two bases, which is this right here. So that's going to be my 7. And I'm going to take half of that. I'm going to divide that by 2. So 8 plus 12, that's going to give me 20. 20 times 7 is going to give me 140. So on the top, I have 140. And I need half of that for the area, which is going to end up being 70. Okay, so I would definitely make sure that you have this formula here written down so that you know what you're supposed to be doing for a trapezoid. Okay. Now, they'll switch up the shape on you a little bit. Again, trapezoid, again, the bases are the ones that run parallel, so meaning they're never going to touch. So these two right here would be our bases. Okay, so I'm going to add up my bases. So I'm going to take 23 plus 15, and I'm going to multiply it by the height, which is the distance between those two, in this case 8, and I'm going to divide that by 2. So when I add up 23 and 15, that's going to give me 38. If I divide that, or sorry, multiply that by 8 up on the top, I'm going to have 304. And I need to divide that by 2, which is going to give me an area of 152. So last one on this page, number 4. Okay, again, finding the area of the trapezoid. Even though this doesn't look like a trapezoid, this is a trapezoid because it has the square with the little triangle piece. This one is a little bit different because they did not give us the entire length of this base over here. They told us this 36. They did not tell us all of this. This 12 only implies this first little section right here. I need to know what all of this is. Well, if this is 36 over on the left, it's going to be 36 on the right. I'm going to add those two things so that I get my total base length right there, which is going to give me 48. So in my formula, I have my two bases, but I also need to figure out what the height is. Okay, so this is where Pythagorean theorem is going to come in. I'm using this triangle. Okay, so I know the 12 and I know the 13. I'm trying to figure out this height right here. So I'm going to be doing 12 squared plus b squared, or whatever variable you want to use for this, is equal to 13 squared. Remember, the 13 has to be the hypotenuse on the right side. Okay, so if I'm solving Pythagorean theorem, again, this is going to help me figure out what my height is. Okay, I've got 144 and 169. If I'm solving this for b, I'm going to subtract, and I'm going to get b squared equals 25. Okay, you make sure you take the square root of both sides, and you're going to get that b is 5. So this distance right here is going to be 5. That's going to represent my height. Okay, so you have to do a little bit more work to get the height, but it's still the same formula. Add up our bases, 36 and 48, multiplied by the height, which is 5, and then we need to take half of that. So in my parentheses here, I've got 84, 84, and I'm going to multiply that by 5. If I multiply that, whoa, keep writing the wrong thing, sorry. If I multiply 84 and 5, that's going to give me 420, and I need half of that. Okay, so my final area is going to be 210. And that finishes up the first page. Moving on to the second page, we're looking at kites or rhombuses that we're going to see here in just a second. So finding the area of the kite, okay, very similar to a rhombus, both of them are the same. So the area formula for this is going to be diagonal 1, which we're just going to call D1, times diagonal 2 divided by 2. Okay, now the diagonals in a rhombus or a kite are the lines that run from corner to corner. So this is the diagonal here, and then this is the diagonal running up and down. Okay, so running left to right, this 3 right here that you see is representing this little section. So this first diagonal that runs horizontally, if I total that up, 3 and 10, my total is going, or sorry, 3 and 7, that's going to give me a total of 10. Okay, if I'm trying to find the diagonal that runs up and down, that's made up of 4 and 4. If I total that up, it's going to give me 8. Okay, my area formula says that I'm going to take those two diagonals, so 8 and 10. I'm going to multiply them, and then I'm going to take half. So 8 times 10 is going to give me 80. I need half of 80, which is going to give me an area of 40. We will use that same formula for a rhombus here on number 6. Okay, so I need to figure out what are the diagonals. The diagonals in a rhombus are equal. They are opposite of a kite. Okay, so a kite might be different as far as different lengths. If this is 24 in a rhombus, then this is also 24. So this first diagonal here that I have in blue, we can add up 24 and 24, and we'll get 48 as one of our diagonals. Okay, they're telling you this right here is 20. That implies that this side over here is 20. If I add those up, that's going to give me a diagonal length of 40. Okay, let's use our formula that we had, which says to multiply those two diagonals, 48 and 40, and divide that by 2. So if I do 48 times 40, I'm going to end up with 1,920, and I'm going to divide that by 2. That's going to give me a total area of 960. Again, anytime we are doing area, it's going to be feet squared, or in this case, square feet. So make sure that you're picking the right label for that. In Math Excel, that's going to be a drop-down menu. All right, looking at number 7, okay, finding the area of the rhombus here. Okay, same idea. We know that this is 15, which implies that this other side over here is 15. This total diagonal length is going to be 30. Okay, then I have to figure out what this is. Okay, now they didn't tell me either of the halves of that diagonal. They told me this hypotenuse over here of 25. Okay, so using what I know about a triangle, here comes Pythagorean theorem again. Okay, this is 25, this is 15. I need to figure out what this is right here. Okay, which we'll just call x. So I'm going to take x squared plus 15 squared equals 25 squared. And I'm going to solve this and see what I come up with. So when I'm solving this, okay, I'm going to subtract 15 squared, move it to the other side. Okay, 25 squared minus 15 squared, that's going to give me 400. And then I need to take the square root of that. So that's going to end up giving me 20. So the length of this part right here is going to be 20. Let's see here. That off of there. Length of this part is going to be 20, which implies that this part is 20. So this entire diagonal length that runs from top to bottom, that is going to be 40. So when I'm thinking about finding the area, I'm going to be taking 30 times 40, my two diagonals, and then I'm going to take half of that divided by 2. So 30 and 40, that's going to give me 1,200. If I divide 1,200 and 2, that's going to give me an area of 600 square inches, or inches squared. All right, number 8 should be pretty easy. No Pythagorean theorem involved there. Okay, you have 24 and 18. So 24 all the way across. Okay, 24 is half. The other half would be 24. That total is going to be 48. Okay, and then I'm running top to bottom, 18 and 18. That is going to give me a total diagonal length of 36. Okay, whenever I'm combining to find the area here, I'm going to do 48 times 36. And then I'm going to divide that by 2. So I'm going to get 1728 up on the top. I need half of that. That's going to give me a total area of 864. Okay, last one on this page. Normally I'd have you guys do this one on your own, but this one is going to be a total length right here made up of 5 and 3, so it's going to be 8. This one right here, 4 and 4, also going to be 8. If I'm finding the area, I'm doing my two diagonals multiplied together and taking half. So 64 is going to be what 8 times 8 is. I need half of that, so my total area is going to be 32. Okay, moving on to the last page, number 10. Okay, find how many square feet of grass are in the plot shown on the right. So it's a little hard to see on here. It will be easier to see on Math Excel. The grass is all of this right here. Okay, and then basically this is like a concrete pad in the middle. Okay, so there is no grass right there. So I want to figure out how much area is taken up by the grass. Okay, so I'm going to have to find the area of this entire trapezoid, and then I'm going to have to subtract off this part right here that's concrete. Okay, because there is no grass there. So finding the area of the trapezoid. Okay, starting out. Okay, we are going to add up our bases, which in this case are 120 and 70. And I'm going to multiply it by the height. So 120 plus 70 times the height. Now, the height in this case is this 70 right here. It does look like a slanted side, but this right angle tells us that it is not. Okay, so that means that I can use that for the height. And then I'm going to be taking half of that, okay, or dividing it by 2. Okay, so I'm going to be taking 190 times 70, and I need to do half of that. Okay, that's going to give me a total area for my trapezoid of 6,650. Okay, that represents the entire trapezoid. Now, I need to subtract off the part that is the concrete, okay, which I colored over here, but it was 60 and 20 feet. For this rectangle here, that's just going to be base times height, 60 times 20. That total inside there is going to be 1,200. Okay. So if I know the total area of my trapezoid is 6,650 and I subtract off my 1,200 for my concrete pad, that will tell me my total area that is grass, in this case 5,450. 5450. Okay. Also, the tornado siren is going off, so my apologies if you hear that on this recording. Okay, last one here is number 11. We're finding the perimeter and the area of the figure. So finding the perimeter of something means we're going to add up all the sides. That should be pretty easy here. Okay, we've got 20. Okay, that is made up of this and this. So we don't know what all these sides are here, but if this is 20, so is this. Okay, I can add those up, and then I can also add up this side here, 9, and then these also make up 9, so 9 and 9. So if I add everything up, 20, 29, and 9, that's going to give me 58 meters. Okay. Now, I'm also going to try to figure out what the area is, which means we're going to divide this in two parts. I'm just going to cut it in half right here. I can figure out what the area of this is by multiplying 9 and 7. Okay, I can take 9 times 7 and get 63. Okay, and then I can figure out this area on this side. So I know the 3, but I don't know this one right here at the top. Okay, I know the entire base at the bottom is 20, and this part at the top was 7. So I can do 20 minus 7 and figure out that this is 13. 13 times 3 is going to give me my total here area, which is 39. So if I add up my 63 and my 39, I can add those and get my total area, which is going to give me a total of 102. Okay, this one is meters and this one is square meters. Okay, so squared anytime we're doing area, perimeter is just regular units. Okay, so you do have an assignment on Math Excel over this. Okay, I would make sure that you have all the notes completed and all the formulas written down. And then if you have any questions, I'll be happy to help you. And you can send me an email if you're not sure about anything. Okay, have a good day.